Hello everybody, welcome to this lesson. In this lesson I'll be running through the geometric progression. A geometric progression is part B of chapter 1. In part A we studied about arithmetic progression. Geometric progression is also a relatively easy topic to grasp. Okay, so let's start. A geometric progression is a sequence of numbers whereby the ratio between any two consecutive numbers is a constant. In arithmetic progression, we spoke about difference between consecutive numbers. In geometric progression, is a ratio. Now, this constant is called the common ratio and is usually denoted by R. Another way to look at geometric progression is that in a geometric progression, each term after the first term is obtained by multiplying the preceding term with a fixed number called the common ratio. I'll be explaining this in detail. As an example, for this geometric progression below here, okay, the common ratio is 2. How did we come to 2? Let's take a look at the ratio here. Okay, I'm just going to write it out here. The R is equals to 10 over 5, which is 2, right? Now if you take a look at the ratio here, okay, this is 20 over 10, which also gives us 2, and the ratio here 40 over 20 is also 2. So the common ratio is 2, okay, and the first term is A, which is 5 here. A geometric progression is typically written in this form: A, and then this is the first term, second term is A multiplied by common ratio. That's what this statement states. In a geometric progression, each term after the first term is obtained by multiplying the preceding term with a fixed number called the common ratio, right? So this term is derived by taking the first term, the preceding term, and multiplying that by the common ratio, which is R. So we get to AR. The next one is AR times R, so we have AR square, and the last term is AR n minus 1. Okay, the formula for the nth term of a geometric progression is as follows: Tn is equals to AR n to power of AR to power of n minus 1, okay, where A is the first term and the R is the common ratio, okay, and n is the nth term. Now let's just recap very quickly. For an arithmetic progression, the difference between any two consecutive terms is a common difference D. Here we are talking about difference, right? So, and the formula is Tn is equals to A plus n minus 1 D, and the D is found by taking term 2 minus away term 1. Okay. Now for a geometric progression, the ratio between two consecutive terms is a constant called common ratio, R, which is equals to T2 over T1. Okay, so in arithmetic progression we are looking at difference, here we are looking at a ratio. Let's take a look at one simple exercise so we can understand this topic better. Show that this is a geometric progression and find x. Now the rules for geometric progression is that the difference or the ratio between two consecutive numbers is a constant, right? And we know that the common ratio R is equals to let's say T 2 over T1. It could also be T3 over T2. Okay, now in this case let's just use this R1 equals to, let's make use of the second and the first term. So here we have 12 over 6, and that gives us 2. Okay, so R1 is 2. R2 is, let's say now we have term 3 and term 2, so that's T3 over T2, and that equals 24 over 12, which is also a 2. So from here we know that R1 is equals to R2, and therefore we can say that this is indeed a geometric progression. The second part of the question, it says that find x. Okay, we also know that this term here, okay, the subsequent term x can be found by multiplying a preceding term with r. So x would be equals to 24r, which is equals to 24 times 2, 48. Okay, so quite a straightforward topic. The only thing is that it's easy to confuse with arithmetic progression, so we have to map out the difference and have a clear understanding of this. Another exercise. Exercise B, find the sixth term of this geometric progression, the sixth term. Now we know that A is 9, right? And we also know that we can find R. Okay, R is equals to, let's say, T2 over T1 equals to 18 over 9, which is 2. Okay, so R is 2. We also know from the formula that Tn is equals to AR to power of n minus 1. So sixth term T6 will be equals to A is 9 and R is 2 to power of 6 minus 1. That gives us 9. 2 to power of 5, which is 9 times 32, and we get 288. Okay, so two exercises to as an example for this topic. I'll be creating another video with a lot more exercises, so you can check back to the website and get those videos as well.